All right, so last week when we last met, we started talking about, when we did talk about writing equalities, right? And we're going to start with this table right here, table 2.7 in your book, and it has lots of equalities in it. I often tell students this is probably a good page if you like to do things like mark a page so that you can refer to it. That's what I do a lot of times. This is a page to put like a sticky note on because you will need to refer back to this page. This page 38, no, 38 in the book. So, now let's think about equalities. If I have two things that are equal, and I take and divide them, okay? If I divide two things that are equal, what does that result in? So it results in 1, doesn't it? Okay? So if we can write an equality between two things, and then we divide them, we write them as a ratio, the result is 1. So if we take that ratio and multiply it by anything, we really haven't changed what we started with, have we? Because all we're doing is multiplying by 1 all the time. Whoa. Okay, so what we're going to do, we're really going to multiply by 1 a whole bunch of times. They're called conversions, okay? Who's had math 110 or higher math where you did dimensional analysis? That's it? That's what you're doing?
Yeah, we're on 110.
You have Ms. Delonzo for math 110. Who do you have for math 110? Sabrina Delonzo.
Yeah.
Yeah. Yeah. I've told her she needs to do lots of that in there. Because that's what we're going to do in here for the next couple months. No, stop saying it. So, we're going to do a lot of multiplying by 1. We're going to start off with some examples today that probably make a little bit more sense, or a little bit more practical type examples. And then, as we move forward in the chemistry world, we're going to change the names of the units. But the process is going to remain the same. So what I'm going to ask you to do today is to start to think about the process and to use my process so that you don't have to memorize, I multiply here and I divide here. Because Dr. Powell doesn't know if you need to multiply or divide. I'm going to write it down and it's going to tell me what I need to do, okay? So if I want to convert from feet to inches, I don't need to know that I'm going to divide by 12 or multiply by 12. Because I don't remember that. But I can write it down and it'll tell me. Fair enough? Okay. So this table has a whole bunch of equalities. And if any two things are equal to each other, we can write them as a ratio that really is writing it as 1. And we're going to use those ratios to do some conversions. And that's what this slide here is to show you that if you have 1 meter equals 100 centimeters, then you can either write as 100 centimeters over a meter or 1 meter over 100 centimeters. It doesn't matter, right? Those two are the same thing. And then I had an email this weekend from somebody. It was a good question. I don't think I responded, or if I did respond, I said, we'll work on that in class. Because the person said, I don't know which one of these I'm supposed to use. It doesn't make sense to me which conversion. Am I supposed to use it like this or like this? They don't know. I said, okay, that's fair enough. But I said, we're going to show you in class and we're going to get there, okay? I try to keep my word most of the time. So, I'm going to insert a new slide. There's a fancy new menu they got here on this thing that they changed this semester. So. All right, so let's go. Now let's do this. Let's start with something simple. Because it's always good if you start out easy, and then maybe we can work out a harder later. Is that fair enough? Okay. So, Dr. Powell, as y'all can tell, struggled with my weight for a long time. Ever since I was about this tall, okay? And a couple years ago, I lost a whole bunch of weight, and then I seem to have gained most of it back. Actually, at one point in my life, I was 310 pounds. Okay, I'm not there right now, thank God. I'm at about 270 right now. At one point a couple years ago, I was like 230, okay? That's the goal, to get back down to there, so. But we don't deal with pounds in this class, do we? What are we gonna deal with in this class? Grams or kilograms, okay? So let's think about a relatively easy problem. Let's say Dr. Powell is 270 pounds. How many kilograms? Okay? So we're going to do a conversion. We want to convert pounds to, or kilograms to pounds, or pounds to kilograms. Okay? Fair enough? So we're going to start off easy. And here's how I approach these types of problems. What unit am I given? What unit do I want my answer to be in? I want my unit to be kilograms for my answer, right? So I have to think or develop some sort of plan to get from pounds to kilograms. Well, I'm starting with 270 pounds, right? Can we develop a plan to get the kilograms? Well, my plan comes from the equalities, doesn't it? Because if I look in that table in the book, it tells me that, what? The equality is 2.20 pounds equals 1 kilogram, doesn't it? Now, we're going to do some of these that are going to have more conversions on them, but this one's pretty straightforward, one step, right? Multiply across the top, multiply across the bottom, then divide. That's going to always work, okay? So in this case, 270 divided by 2.20 tells me that Dr. Powell weighs about how many kilograms? 130. Somebody said something. Who said it? What did you say, Tonica?
Well, it says 122.7.
122.7. What do you think? Where do we got to round it to, Tonica? Where do you think we should round it to? 123? Who agrees with that? Who disagrees with that? How many sig figs in this number? I said away about 270. There's no decimal there, is there? So it's only 120 kilograms. See, I actually lost weight just by rounding it off. Sweet! God, I like that system. Huh? That's better than Jenny Craig right there. Y'all don't like that system? That's pretty nice, isn't it? No? If it only worked that way, huh? Okay. Are we ready for more examples? You can do this in everyday life. Okay? Let's think a good example. This class, on average, the population of this class is, let's put it a nice way, more mature than the other section. What does that mean? Y'all are older. So in the other class, I use an example going on spring break. Y'all probably don't go on spring break. You going on spring break? Where are you going? Panama City? Gonna go down there and act a fool? Why not? That's what I used to do. It's a little dangerous these days. People act really stupid. Let's say we're going to do a nice family vacation. We're going to go to Disney World. Who's ever been to Disney World? It's a wonderful place, except for one thing. Holy Jesus, it's expensive, right? You can spend money at Disney World like nobody's business. And they'll take all of it. They don't care. They'll take all of it. What's the problem with doing that? You got to get home, don't you? And if you drive, You gotta buy gas on the way home. You don't believe in credit cards. You're gonna pay cash for everything. Fair enough? Okay. So the question becomes, how much money does it cost, do you have to save to get home? How far do you think it is to Disney from here? Maybe about 800 miles or something, huh? Pretty far. Okay, it says 800 miles. We'll put a decimal on that. 3 sig figs. Price of gas is $1.76 a gallon. I need to fill up today too. What kind of mileage you get on your car? Anybody ever calculate their mileage in their car? What do you get?
Depends on what I'm driving. But if I'm taking the family, I'd be driving the van, so I get about 23 on the highway.
Minivan, don't you?
Yes.
Oh, that's sad. Anybody have a car that gets good gas mileage? Highway, you get 23 highway?
I get 43 highway in my car.
Okay. We have a Prius or something? What do you have that gets 43?
A Hyundai.
A Hyundai. What kind of Hyundai?
Sonata.
Oh. We got an Elantra. It doesn't get that good, I don't think. 28's not that good. We definitely don't want to take my truck. My truck gets like 14. We have to save too much money. We can't buy ice cream. And believe me, ice cream at Disney World is worth eating. It is good stuff. Let's say your car gets, would you say 43? 43 miles per gallon. How much money do you have to save to be able to get home? That's the question. Calculator. He just grabs the calculator and starts punching in numbers. I hated it. Hate it. Can't stand it. Where do you think you're going to start? Always start with a number that only has one unit on it. What are the units on this number right here?
Per gallon.
It has miles per gallon. What does that mean, per gallon?
For every 1 gallon.
That means, yeah, 43 miles equals 1 gallon, doesn't it? What about this one right here? $1.76 equals 1 gallon. So we can't start with these two because they're both conversions, aren't they? So you're going to start here. Start there and see where you can go. Let's see if you can get there. The whole point here is to learn the process, not to get the right answer. If you learn the process and practice the process, what happens? It becomes easier to you, and so when we change these words, instead of using miles and gallons, and we start using moles and grams and atoms and molecules and things like that, it makes more sense to you, okay? Write it out. Don't just punch numbers in the calculator. Do y'all need my help? What are you going to change miles into? What do you think you can change miles into? What can you change miles into? Do you have another unit on there that has miles in it?